Newton's second law of motion. According to this law, the force acting on a body is directly proportional to the rate of change of linear momentum of the body, and the change in momentum takes place in the direction of the force. This law helps us to measure the amount of force. So, it is also called as law of force. Let m be the mass of a moving body moving along a straight line with an initial speed u. After a time interval of t, the velocity of the body changes to v due to the impact of an unbalanced external force F. Therefore, initial momentum of the body Pi is equal to m into u. Final momentum of the body Pf is equal to m into v. Change in momentum, that is del P, is equal to Pf minus Pi, that is mv minus mu. By Newton's second law of motion, force F is directly proportional to the rate of change of momentum. Therefore, F directly proportional to change in momentum divided by time. F is directly proportional to mv minus mu by t. In order to make this constant, we have to multiply with the proportionality constant, that is k. That is, F is equal to km into v minus u divided by t. Here k is the proportionality constant. K is equal to 1 in all systems of units. Hence, the equation becomes F is equal to m into v minus u divided by t. Since acceleration is equal to change in velocity divided by time, that is a is equal to v minus u by t, hence we have F is equal to m into a, that is mass into acceleration. No external force is required to maintain the motion of a body moving with uniform velocity. When the net force acting on a body is not equal to 0, then definitely the velocity of the body will change. Thus, change in momentum takes place in the direction of the force. The change may take place either in magnitude or in direction or in both. Force is required to produce the acceleration of a body in a uniform circular motion even though the speed, that is magnitude of velocity, remains constant. The direction of the velocity changes at every point on the circular path. So, the acceleration is produced along the radius called as centripetal acceleration. The force which produces this acceleration is called as centripetal force, about which you have learned in previous classes. Units of force. SI unit of force is Newton, and in CGS system its unit is dyne. Definition of 1 Newton. The amount of force required for a body of mass 1 kg produces an acceleration of 1 meter per second square. That is 1n is equal to 1 kilogram meter per second square. Definition of 1 dyne. The amount of force required for a body of mass 1 gram produces an acceleration of 1 centimeter per second square. That is 1 dyne equals 1 gram centimeter per second square. Also 1 Newton equals 10 power 5 dyne. Unit force. The amount of force required to produce an acceleration of 1 meter per second square in a body of mass 1 kilogram is called unit force. Gravitational unit of force. In the SI system of units, gravitational unit of force is kilogram force, represented by kgf. In the CGS system, its unit is gram force, represented by gf. That is 1 kilogram force equals 1 kilogram into 9.8 meter per second square, which is equal to 9.8 Newton. 1 gram force equals 1 gram into 980 centimeter per second square, which equals 980 dyne.